Hello and welcome back. This is for the grade 10 applied math course, and this is the unit 4 similar triangles, and this lesson is actually lesson 3, and it's also called similar triangles. So for the learning goals for this lesson, by the end of this lesson, you will be able to decide if two triangles are similar, and you'll also be able to determine the lengths of sides in triangles using proportional reasoning. So that proportional reasoning is from our last lesson. So taking a look at the lesson here, similar triangles are triangles that have corresponding angles that are equal and corresponding sides that are proportional, which means that they have the same constant ratio. So the word corresponding angles, that just means that the angles that would be in the same spot. So I'm just outlining here. We would see that these would all be equal because they are all in the same spot. And I know that these are similar triangles, that's why I'm drawing these in. So this first example is actually talking about the sides. So the corresponding sides again mean the same position. So this 10 here corresponds with the 20. The 5 corresponds with the 10, and the 12 corresponds with the 24. So it says these two triangles are similar because their ratio for length of their corresponding sides is, and the way that you figure that out is you can take the larger triangle and take each of the sides and divide by their corresponding side. So 10 corresponded with 5, 10 divided by 5 is 2. 24 corresponds with 12, so 24 divided by 12 is also 2. And the last one, 20, corresponds with 10, and 20 divided by 10 is also 2. So we know that the ratio is 1 to 2, because if we take that smaller 1 and we multiply by 2, we get the second one. For figure B, it's very hard to see, but the angles in here, all of the top ones are 60 degrees. And all of the bottom ones are 30 degrees. Okay, so these 3 triangles are similar because they all have the same corresponding angles. Okay, in brackets we can say corresponding angles are equal. Okay, further down here we see that there is a definition for corresponding sides, corresponding angles, and proportional. So in case I didn't explain it well enough, these are the definitions. A corresponding side, this is a side or sides that have the same relative position in a pair of similar triangles. Corresponding angles have the same relative position in a pair of similar triangles and are equal. And two things are proportional. If there is a number that we will multiply all of the other side lengths of the first triangle to get the side lengths of the second triangle. Okay, a note here, when naming similar triangles, we list the letters of the corresponding angles in the same order for both triangles. So this is super important. This is going to really help you on some questions, because if you know the order, you'll be able to match up the angles much better, as well as the sides. So for example, given similar triangles A, B, C, and M and P, we know that angle A corresponds to angle M, because they're the first in each one. Angle B corresponds to angle N, again, because they're the second thing in each. And angle C corresponds to angle P because they are the third in each. Okay. Also, we use the symbol, this squiggly line that you would find on your keyboard to the left of your 1. We use that to say similar. So we could write triangle ABC is similar to triangle MNP. If I needed to draw these triangles out, I don't know exactly what they look like, but you could have a rough sketch that looks something like this. MNP, and again, make sure that the letters are in the same position. Try to draw similar triangle here. So MNP, A, B, C. Okay, so looking at example 1, given that triangle ABC is similar to triangle DEF, find the length of X. To do this, we have to set up a proportion. Before we do that, I just want to go through and set up a proportionality statement for this triangle so that you have an example of what a proportionality statement looks like. Okay, so we know that side AB corresponds to DE. So we can say AB over DE is equal to, now I go back to that original triangle. BC corresponds with EF. And going back to that original triangle, so on the top we should all have ABC. Side CA corresponds with side FD. Okay, so just take a quick look. We have ABC on the top and DEF on the bottom. Okay, now if we wanted to solve, we could take part of this. We don't have AB or DE, but we do have all of this. And what I mean by that is for side BC, we have 24. For side EF, we have 16. For side CA, we have 21. And for side FD, we have X. So we can take those 4 things and put them into our proportionality statement. So we have 24 over 16 is equal to 21 over X. And now this looks very similar to what we did earlier in the lesson for 4.1. So if we want to solve for X, we can just cross multiply. So we're going to cross multiply here. So we have X is equal to 21 times 16. And then remember that whatever gets multiplied by X is what we're going to divide by. So divide by 24. And if you do that in your calculator, 21 times 16, divide by 24, hit your equal sign, you should get 14. Okay, so then we can say, therefore, the length of X is 14 units. Okay, taking a look at example 2. It's kind of hard to see here, but we have this is an X, this is 10, this is 15, and this is 3. So it says, given triangle ABC is similar to triangle ADE, find the length of X. For something like this, I would suggest redrawing it as 2 separate triangles. So we have the larger one and the smaller one. For the smaller one, it was DAE, and we had 10 and 15. For the larger one, we have BAC, and we are not sure what this full length is. And we have the bottom length here is 15 plus 3, which gives us 18, so that's 18 here. we're trying to find x, which is part of this longer side here. So I'm actually going to call this y for now, because we need to find the long side first before we can find the whole thing. So to set up this proportion, I like to start with the variable I'm looking for. In this case, I'm looking for y, and y corresponds with 10. Then I create my equal sign and the other side of the proportion. So whatever triangle I started with at the top of my first fraction, I have to go back to that triangle and pick a different side to use. So now I'm going to use 18, and 18 corresponds with 15. So again, take a quick check. Your top should all belong to one triangle, and your bottom should all belong to the opposite triangle. If they're reversed or something's wrong, then it's not going to work. So just take that visual check. From here, we are just cross multiplying and solving. So we are doing y is equal to 10 times 18. And then we're dividing by 15 because that's what's across from the y. Use your calculator, do 10 times 18, and then divide by 15. You're going to get 12. Now be careful, that's not what x is, because remember that 12 is this whole piece here. So to find x, we can say x is equal to 12 minus 10, and x is equal to 2 units. Okay, taking a look at example 3. So this one is a little bit tricky because there's quite a few unknowns. You should see that there is one large triangle, so I will redraw these as 2. I just think it's easier to really visualize it. So we have 2 right angle triangles. The height of my larger triangle is 12 and the base is 9. And now for my smaller triangle, we have z and x. With 2 unknowns, this is going to make it very difficult. So the first thing that we're going to do is, you might notice that this is a right angle triangle. We should be able to find this side here. And I'm actually just going to call it C because that's these 2 pieces together. So I'm going to call it C. Okay, and I'm just realizing I forgot that there's also a 9 here, okay, for the smaller triangle. Okay, let's find C. So C squared, we're going to use Pythagorean theorem, is equal to A squared plus B squared. So C squared is equal to 9 squared plus 12 squared. And if you did that in your calculator, 9 squared plus 12 squared, you're going to get 225. We don't want C squared, we just want C. So in order to get that, we have to square root, and whatever you do to one side, you must do to the other. The square root of 225 is 15. So we know that this whole thing is 15. Okay, now that we have the longer triangle with 15, it's going to be easier to use 2 pieces at a time. So what I mean by that is you can only use 2 fractions when you're creating a proportion. So here we have 9 that now corresponds with 15. Before we didn't have something there, so we couldn't solve. And now we can solve for x and z. So we have x here that corresponds with 9. So I'm going to set up a new proportion. This is going to be x over 9, because that's what it corresponds with. And then go back to your original triangle we were working with. So 9 over, and it corresponds with the hypotenuse of the larger triangle, which is 15. Now we can cross multiply and solve. So again, we're doing 9 times 9, and then dividing by whatever's across from x. So use your calculator, 9 times 9 divided by 15, you're going to get 5.4. Okay, now to find Z, it's totally your choice how you would find Z. We can find Z by doing Pythagorean theorem again, or you can set up another proportion. So we have X, let's find Z, and then we'll have to actually go back and fill in Y. So for Z, I'm going to use a different color now. So Z corresponds with 12, and then going back to that original triangle, I'm going to actually use 9 and 15 again. 9 corresponds with 15. So Z over 12, and then go back to the triangle that contains Z, 9 over 15. Okay, you could have used the other side, which had 5.4, and then 9 on the opposite triangle. I just prefer not to use the one that had decimals. So again, cross multiply and solve. So Z is equal to 9 times 12, and then we're dividing by 15. And 9 times 12 divided by 15 gets you 7.2. Okay, so we have X and Z. Last thing we need to do is just find Y. And if you notice, this whole piece is 15, but we know that X is equal to 5.4. So we can say Y is equal to 15 minus 5.4. And that's going to get us just from here to here, which is Y. So 15 minus 5.4, if you use your calculator, you should get 9.6. Okay, so that's the end of this lesson, and the homework for this section is on page 16 and 17.